Welcome everyone to our Friday webinar. I am Pamela Schultz, and I believe David is going to try and join us as well. We are talking today about data analysis types within DataGraph, and specifically focusing on the types of graphs that are in DataGraph that both visualize data and perform calculations with data. And great, and David has joined us, and he is David Adelsteinson. He's the developer of DataGraph, and so I thought it would be useful to have David join us initially to talk about some of the way in which DataGraph is different than a lot of other types of graphing programs, and in particular, the idea that DataGraph has a data flow mechanism. If you joined us last week, then you know we showed you a bunch of different graphing types that we went into, where you have a set of data and you make a line graph or a box plot. And that certainly is a way of analyzing data, obviously, is visualizing it. But the commands that we see today go a step further because they also do calculations. Today, what we're going to focus on are things like histograms, displaying distributions. We're going to talk about box plots, violin plots, and honing in more on those types of graphs, a little bit about the pivot command, but all these commands that also do calculations. So David, if you want to go ahead and share your screen and talk a little bit about the conceptual aspect of the data analysis and DataGraph, that would be great.
I decided to kind of go in a little bit into how things are computed and how things are interconnected. So it is a directed graph because every node in the graph has a connection to another node, and there is a direction to that node. So A directs to B, B directs to C, D, and A also goes to D, A also goes to C. So this is how things are really computed behind the scenes, and so here you have the various kind of drawing objects in here, and they're connected in the sense that the A column is used inside the B column because B column is referencing A. And that's this link. A is used in C because C is here, and A is being used as one of the inputs into that. So it really pulls data from the A column to compute the C, in this case, value. The D, which is here, uses A and B and C. So that's this here and here. And now the E column, E entry, which is this guy here, really, is using A, that's from here. It uses D, that's from here. And then I folded in, just because I sort of wanted to put that into the C, is also being pulled into that command. So this is how things are connected. Now, this connection here is graphical way of displaying a connections or relationships. DataGraph has that in between, but is not displaying this for you this way. It's displaying it in kind of grouped by object types. Like there's the columns, there's the numbers, and then there's the commands, right? And there's a level of another group, which is the graphs, and that is just one more category of objects that you can have. So every node here is an object. Every object is referenced, these are different object types, and this is yet another object type. So that is how DataGraph kind of maps the objects into the connections.
Now, and I think one of the things I just wanted to point out, one of the things that are different in the files that we'll look at today, similar to what you're showing right now, David, is that you have the B and the D column are computed values, and they're bold, which is one way to know that these, just visually, those depend on something else.
Bold,
right? What? In the data table itself.
In the data table, yeah. Okay, so in the data table, you can sort of see there's an indication here that you can modify this entry, but you couldn't modify this entry, right? So this is displayed a little bit because this is computed, and this is something you could modify. If you think of this as a production pipeline, right? So that means that this guy here will create something that then this uses. So that relationship, that direction is considered that from A's point of view, this guy is a client of its calculation or client object. And from B's point of view, it has the D as a client and A is then a supplier. So from A to B is a supplier-client relationship, and going backwards is a client-supplier relationship. So the way you can see this here is that there's a menu, and you can go, certainly if you go into, say, the C object, which is here, there is a supplier object, which it says my supplier is A. That's going back up into the tree. And to see that, if you hover over that, you can, the UI kind of shows you where this is being used, that this one is inside the arrow points to the supplier here. E is this drawing command and D is this. So you can navigate through you're sort of seeing that little sort of portion from the point of view of C. This relationship going back is the client, and this is sort of supplier, and this are the clients. So you don't see the entire graph, but you see kind of from the node from where you are. And that is helpful when you get a much larger graph, because this is a very simple relationship in between, and already you have kind of a graph that looks a little complicated. Once you get into more intricate sort of graphs types, this view of the interdependencies becomes really complicated. So it's much better to look at it from the point of view of like going, and you can nest this. So you can go into the clients here. There's no supplier, so that isn't even displayed. You can see that, oh, I have a B object that has a D object and that has an E. So you're navigating through that pipe going from A to B to D to E. There's A to B to D to E, right? That's the view that you see. And you can see the arrow kind of points out where you are. That points this, points that, points this, right? Yeah. So the B entry is this, the D entry is down, and then E is this. Okay. Now, what are the benefits of this, right? The one big benefit is that when you change something, let's say that I change the C entry here to be A+1. What that kind of means is that since C changes, these guys don't need to know about that because they don't need any use of that. But C changing will affect D and E. So DataGraph uses this extensively. So when you modify something, it does what is called an incremental update, which is only these guys get modified. So if there's a big calculation going on from A to B, that is not affected. Now, this is very different than, say, a Python program or any normal programming language, because you don't have that, even though there is a DAG in it behind the scenes, you never really view it that way. You run it from start to finish, you're rerunning it. So if something changes in the beginning, you can't just run the code from then on, you have to start it all over again. So if there's a complicated action followed by a simple action, doesn't matter, it needs to run the whole thing every single time. So incremental evaluation and intermediate caching, which is very connected to it, really gives the program an opportunity to be very efficient at updating things. So that hopefully describes kind of the connection, how it relates to graphs and how that is expressed in the UI, and hopefully gives you kind of a sense of why would you be okay with doing things, changing things on an otherwise complicated graphic, because it really is only updating little pieces of it as you need them.
Okay, great. That's great. So, and we'll illustrate this concept more as we look at some of the examples that we have online. just again, for anyone listening, so David, what again was this concept is called a DAG, is the acronym?
It's an acronym for a directed acyclic graph. So directed is because of the directions here. Cyclic means that there's no cycles in it. There's no way to go from A to B to D and then back to A, because that would be a cycle. And that means that this is if you were doing that, certainly in a relation, clients can be suppliers and vice versa. For the same relationship, you can be a client and supplier of your supplier and client, right? That would be a kind of sort of something that marches out in time. The benefit of a DAG, which it does not have the cycles or acyclic, is that you can evaluate it completely. There's no looping on it. You can update it completely, and that's it. There's no recurrence.
Yes, and that's how DataGraph works. It's everything gets updated at the same time.
You can see how D cannot be selected here. And that's a circular thing is because that's the cycle, because that would cause a cycle if you selected it. So it stops that from even being doable in the UI. Or in the expressions, if you have this guy here depend on itself, it's going to have, well, it doesn't even see it because it excludes it from its point of view.
What I want to start talking about are, in terms of graph types, are histograms. So if you go into the file, online examples, go to analysis, and then start typing in histograms, you'll see a whole bunch of variety of different types of histograms. And so there's not just, again, like many of the commands, there's not just one thing that the histogram command does. It can do a lot of different types of things. I wanted to start by just looking at the simple histogram here. And this is a file that we recently did an update on. So you can see, similar to the basic graphs we went through last week, on the left, the tile shows you how can I quickly create this, where you simply need to highlight a single column of data, and then you can add the histogram command, and you can see the histogram of this data here. And what you see that's different than the graphs that we looked at last week and the files that we looked at last week is that this file has a column that, again, these are bold font here to indicate that. They also have this little dot here up in the top right corner, and this indicates that these are columns that are coming out of a command. Okay, so in terms of creating this, I'll just demonstrate it really quickly here. Again, clicking on a single column, the histogram command can be found under the draw menu in DataGraph 5.0, and you'll see down here there is a histogram, bin numerical data, or plot cumulative distributions. I'll click add, and then I create the graph that's in this. And what this file is showing you are that there are a variety of ways that you can format the histogram itself. What is a histogram doing? I guess just to be clear, the graph that you see here is looking at ranges on the x-axis and counting the number of values that are within a particular range or bin. And you can change this more to look like bars, but again, this is really doing an analysis. You can change the units here to on the y-axis. We'll talk about this a little bit more. I'm going to show you another example where we compare histograms. You can also show things in terms of cumulative probability. So it shows you how you can do that here. And there's also a smoothing option as well. So a number of different things that the histogram command can do. What I want to just point out to you before we move to the next example is how did I get these two columns, this location column and this value column, for anyone who's not familiar with this. Then on all of these commands that do types of data analysis, that are performing calculations. Well, I guess one thing, just again, for those of you who may not have seen this before, when you expand these commands, you'll see a table in the inside here that shows you values that are being calculated. But then if I want to bring this back out into the data table, I can click the gear menu and you'll see these extract options. So you can extract individual variables, you can extract columns. The histogram command also has this option, append histogram information as columns. So if I click this, then it just extracts out both the location and the value of where the bins are. And I don't need to repeat them here, but let me just show you quickly, again, this idea that everything is being updated, what do these columns depend on? So if I opened up this file and I had no idea how this was created, which histogram, for example, do these columns depend on? I can click the gear menu. You'll see there's no clients. There's nothing currently using this column, but there are suppliers, and I can click on this and it shows me, it happens to be the histogram of the graph I've selected, and then it goes back to show me what column is being used. I have found in DataGraph this concept of clients and suppliers to be so helpful in terms of being able to track what I'm doing, and in particular, going back to files that I may have created, a week ago or a month ago or years ago. It makes it really easy to see what's being used, where are things coming from. Are there columns that maybe I created that they have no clients? Maybe I don't need them anymore. Here, this is just showing how you can output the values. And maybe the last thing I'll show with this one is the fact that I can change the bin sizes. This is all very dynamic. So I can change the bin. I can type in a specific bin size if I want a specific value, but you can see how this output is being just immediately calculated when I change the values of the bins here. Okay, the next graph that I want, or file that I wanted to open, is actually one that I just uploaded that I wanted to really hone in on one aspect of the histogram command, because I thought this was so important and I wasn't sure if there was the perfect example. So anyway, if you go into the online examples, you'll see a file now called 2 histograms. So if you open that one up, I guess the default here is just showing you the single histogram made on this one column of data. You can see the result here. But what I did in these subsequent files or subsequent graphs is to separate the data into 2 different columns. Actually, this is actually a good example of clients versus suppliers. I was playing around with this data a little bit. I have this column here. This is actually not being used. So as I'm going back to this file in real time, I can say, yeah, I actually don't need that column. That wasn't what I was using for this. So anyway, so here's my data. And if you go into either of these drawing commands, you'll see that there is a mask based on the column group. And you see that arrow showing you, what's being used. And it's only including in each of these graphs, either where the group is equal to A, or in the histogram command below where the group is equal to B. So in terms of creating this, it's really just creating a single histogram command, but then making a copy of it. So I can use, my favorite technique is holding down the Option key, clicking and dragging, makes an exact copy, and then you can use this mask to set up what you want to include. Again, group matches A, for example, and then splitting the x-axis, I can place each one of these on either side. Now, one handy trick, if you weren't aware of this, once you create the mask once, I can use the gear menu to copy that mask and paste the same mask into my second graph. That just saves a few clicks, and then I can make this using the B data. So that's really, how this is creating these side by side. But what I want to point out to you specifically is the fact that by default, what the histogram command is doing is it's, again, counting in the bin. But if you want to compare between distributions, you have to be really careful about this, because in this graph, for example, here I'm using the automatic setting. Let me actually swap my layout here so that we can see this a little bit better. So the other thing to pay attention to is right here. Whoops, using the wrong. Sorry, here we go, the units. So here the units are counts, the bins are automatic. But if I change my bin to be something different between these two, you can suddenly get a sort of a strange representation of how this data is related. It almost makes it look like there's more data on the histogram on the left-hand side than the data on the right-hand side, because again, the y-axis is just purely the counts. And when you change the bin size, you change the counts for each bin. So the way to do this, or one way to be careful, well, one way would actually be just you can set the same bin size for each histogram, but there's a setting built in to this to change the units here to density. And when you do that, the area under the histogram is going to be equal to the count of the data that's with the number of values. And so then if I change my bin size on either of these, it changes a little bit how this looks, but you're not getting that effect of making it look like the other data is smaller than the other or larger than the other. So that's a really important option to be aware of here. And the last one here that I'll show you is now the units are set here to probability. And this is now scaling both of them based on probability. So the area under each of these is equal to 1. So you can see there's consistency between each of these two commands. You're not seeing the fact that there's a lot less data on the left-hand side than the right-hand side, but you can see what the distributions look like. So this is helpful if you have two data sets where maybe they both have a very similar distribution. You can see that, but maybe the amount of data you have in each is very different. So the choice you use is really dependent upon what your data is and what you're interested in looking at. Okay, so I'm going to go ahead and let's move on from this file. And hopefully that makes sense, because it's something to play with your data, because the other commands that I want to talk about, in particular, the box plot, has a bunch of other different options that also depend on this idea of whether you're based on density, whether you're representing a distribution based on the density or the counts, or you're showing it based on the scaling it based on the probability. But first, let's just go ahead and look through. Again, if you search on box, you get a long list of different types of box plots that are used in a variety of different ways. And again, the box command can do a lot of different things. You see here, this is a points and mean graph. This is created using the box command. So it does a lot more than just box plots. Let's open up the one that says simple box plot. Here it is. And again, you see here some output coming out of the commands, the category, the median, the mean. These are now grouped into these groups, so you can collapse them and easily hide them or show them, whether you want to, include them. Now, in this case, whereas the histogram does just a sort of a single distribution, the box command can look at multiple data sets and very naturally can categorize the data. For the histogram command, I had to either have things in separate columns or use a mask like we did in the last example. But here, to create this, if you look at just the simple one here, it's really simple. I can just highlight both columns, go to the draw menu, go down to my box command, and I've created it, and my x-axis has everything labeled categorically. So you can see treatment A, treatment B, treatment C. What this file also does is it shows you options for showing the median on the graph. It also shows you how you can map the name of the category that's used to break up the data to a different label. So I have a table within my DataGraph file that shows me here treatment ABC. I have a short name that I'd prefer to show, and you can do that naturally within the command itself without having to change your data in any way. So if you look at this command, I'm not sure we're going to get through all of these different types. So I just really want to show you how do you change the box, using the box command to all these other different graph types that are available. And that's done under the type menu. So if you click this, you'll see points, probability, histogram, violin, and then these smoothing options here. So these do all sorts of different things. So if I want, for example, to have a points graph, then I can click this, and now you see all of the points shown that are the underlying data for those box plots. So the trick here that's really useful is to, again, make a copy of this. So I could hold the Option key, drag that to make a clone, and have one as points and the other one as whisker, and just overlay the two of them. And each of these has different options. So when you change it to points, you'll see other options available here that you don't have when you have the whisker setting. For example, you can do color schemes for your points, all sorts of different things. Okay, I want to show you one other, we'll show this one, the binned box plots, because I think this does a nice job of showing you, again, other things you can do with this box command. Yeah, last week we talked a lot about how we have the bar command and the bars command. That's these two up here, and how the bar command uses a numerical axis, but the bars command uses a categorical axis where you see, things on, they're still on an XY scale, but we group things in categories and we show the axis in that way. Well, so that last example was showing you again, was categorical. We had treatment A, treatment B, treatment C, and everything grouped according to that. Here, we have an example where we're actually taking the values to make the histogram. So one column of values in the histogram, but we're positioning the data along the x-axis using a numerical column. So here's my numerical column, and I can change the stride of the bins that are used for these. And when I do that, I can also change the width associated with them. The last thing I'll do, I'll just point you to checking this out. Again, all done with the box command. You have these sideways histograms that you can create. This is using a probability type. These are, again, scaling mini histograms on the x-axis based on probability. If you change it to the histogram setting, then you see a little bit of a different look. Well, first of all, we might want to adjust this a little bit in terms of the height that you see, but the The histogram option is more like the counts. It's based on the density. We can, again, change these to violins, and you can have the violin based on the probability, or you can have the violin based on the count. So for this data set, it actually doesn't make any difference because I have the same, you can look here at the little table that's in this, I have the same number of values in each bin. So whether I choose violin PDF or violin count doesn't actually make a difference. But if you had very different numbers of entries in the bins, then you would see a difference between these two options. Again, one based on probability, one based on counts. And just to round this out here, here's the smooth histograms. Again, you have a number of different settings in terms of how these are done. And I think there's been a lot of interest in not just using box plots, but using representations like you see here, because you get more information potentially from the data. So the same data you see here binned in this way, when I show it with the box plots, for example, this graph or this box just shows one box that everything is grouped in. But if I looked at it on my sideways histograms here, you can see how there's almost a bimodal shape to this, indicating that maybe my bin stride should be maybe a little bit smaller, for example, to actually separate out that data. And then I might want to, change my heights here a little bit. Yeah, there's a question to us that adding the mean and the 95th percentile confidence limit to the violin plots. And David said you can add those to the box and whisker method. We've been working this week on specifically adding the confidence limits as another option in here. And it's not quite there yet, but we're going to do that. I thought we'd maybe have it for today, but basically what we're working on is another option in the type menu that would allow you to layer a single interval. So you could show the mean or the median and then some interval around that. What you can do now is in the box command itself, there is an option. Now, this is not the 95th percentile confidence limit, but you can show the percentile value within the graph itself. Actually, I don't usually do this, so
This actually is just to extract it out as a column.
Ah, okay. But there's a way to show it as, it's under here, right? The percentages. Yep. This is it. Okay, so this is changing the box to add in specific percentages within the data. So these are not the confidence limit in terms of actually, looking at the distribution, but these are the percentile values within the discrete data set.
Yeah, because the box plot shows naturally the 25th percentile, the 50th, and the 75th, and this would allow you to add additional lines as little hashes. Now, that is because of that big box in the middle. It's not easy to overlay that with the violin, so it doesn't. I mean, you could do it, but the box is going to be in the way.
Yeah.
What we're talking about is something that is less, kind of not as visually big, and is better, has these hash marks, which you then, if you overlay it on a histogram or violin, you could make those lines sort of like indicate things in the violin.
Yeah, and I think we're definitely working on, again, that interval option so that you can show that line over the violin plots. Just to sort of kind of round out this section a little bit. And if anyone else has any other questions, feel free to pop them in, but we'll go ahead and probably end pretty quickly, or end in a minute or two if we don't see anything. But this section on analysis, if we go and just look at the whole group here, there's also a lot of examples on curve fitting, functions. What I think would really actually be useful would be to separate those out into a separate category within this. So you can, but if you want to, look at those, there's a lot of other stuff in here, all these examples with functions. There's also the scalar field, which didn't want to really go into that today. We've done other webinars on that. But the other one, maybe just to also be aware of, would be pivoting. The pivot command within DataGraph can do all sorts of different things. Again, the idea of whether you have categorical or numerical data on your x-axis, whereas the bars, you have to choose one or the other depending on which one you have. The pivot command can do either. It can look at numerical data. It can group numerically, sort of the way we were showing that with the histogram command, but it can also group categorically. So the pivot command does all sorts of different things. And again, we've done, I think we had a whole webinar on the pivot command back in the fall. So I wanted to sort of focus on some other things today. Next week, what we are going to talk about are the graphs that are in this section, in the layout section. And here you have graphs being combined, panel graphs, constructing different types of graphs, and thinking about, when you're publishing and how to really modify that layout. So that'll be the focus of next week. We'll probably add a couple of new examples in this graph or in this section for next week as well. So I think we'll go ahead and end for today. I hope that this was helpful for you. And again, this idea of clients and suppliers, this may be something new to you depending on what your, how long you've used DataGraph, but I think it is I think it's so helpful. I don't know if any of you have ever used the audit function within Excel. Back in my spreadsheet days, I remember having to use that to try and track a calculation to see, where did these cell references, where did they belong, where did they come from? And it could be really difficult to track where things were coming from and to figure things out. And particularly when you had things going between worksheets, in DataGraph, the fact that you just have everything there in front of you, I think it just makes it so much easier. So with that, appreciate everyone attending today, and we will see you next week. Have a good weekend.